Take a look at some graphical limits. So now all we're given is this picture of a function called f of x, and then we're asked about some of the limits for this function. So we'll start with kind of, a more straightforward idea here. So we have the limit as x approaches -2. So what we do is we head over to -2, we think about as we're approaching from the left, as we're approaching from the right, what is the y value that we are approaching? And are we approaching one y value? And as you can see, we are approaching one y value, and that is 0. Okay, so if you want, you're welcome to try. Say the next one if you'd like to do that. For the next one, we're approaching x equals 1. So what you want to notice is as we're approaching 1 from the left and as we're approaching 1 from the right, we are getting close to a value. It is not the value of f of 1, but that doesn't matter because with limits, we're just seeing, are we getting infinitely close to a y value? So you'll want to notice that we are getting closer and closer to the y value of 1, although it does not actually exist at that point. We are getting infinitely close from either side, so that is our limit. So for the next one, we're approaching -3, and this is going to show us kind of an interesting idea. So notice as we come from the left-hand side, we are approaching a y value. As we come from the right-hand side, we are approaching a y value. We are getting infinitely close. Our function is getting infinitely close from the left-hand side and the right-hand side. However, it's not the same y value, and that's the problem. If you're asking for the limit as x approaches -3, you need to be approaching from the left-hand side and from the right-hand side the same y value. Otherwise, we say dne, which does not exist, and that just tells us that the limit as x approaches -3 does not exist because we're coming to different values from the left and the right-hand side. You'll notice something similar as x approaches -1. We can see that as x approaches -1 from the left, we are approaching a y value. And as we come in from the right, we are approaching a y value. Those are both different than the actual y value, f of -1. However, the big thing here to see is because we're approaching -1 down here and we're approaching -1 up here from either side, we don't have a limit that exists because it's not the same value that we're approaching. So in that case, we can just say another dne, But we can get a little more specific and do what's called right-hand limits, left-hand limits. So notice the right-handed limit is going to come in from the right-hand side, and you're going to see this little positive sign. So we're coming in from the right-hand side if you see that. So all it's asking is what is the limit as you're coming in from one side, and that might work, that might have a value even if the other side doesn't. Coming in from the left-hand side, you're going to see this little negative value here. And again, if you see those, it's just asking you about one side or the other. Now, notice, this is a big thing here at the bottom. In general, if you want your, to have a limit, so if the limit as x approaches a of f of x equals L, that is true if and only if your right-handed limit equals your left-handed limit equals the limit. And so that's, the key thing to see is that you have to be coming in from the right-hand side and the left-hand side. Those things have to agree in order to have that limit. Okay, just a little bit more from this section. So now we have something that you might think, oh, we saw something kind of like that before. But actually, it's a little bit different. Notice that we're approaching 1 from the left-hand side. And the numerator is x plus 3 and the denominator is x minus 1. So if we were to just think about plugging in 1, I want you to notice that when we plug in 1, the numerator would be 4 and the denominator would be 0. Now that's kind of a weird thing to think about because you cannot divide 4 divided by 0. However, what we'll notice, we'll plug in some values, we'll do this numerically. So we're trying to get close to 1, but from the left-hand side. So we're approaching 1 from the left-hand side, so we'll try to get kind of as close as we can, as quick as we can. 0.999, like this. And then we'll put that into the numerator, each one of those values into the numerator and the denominator, and see what we get. Ooh, okay. So what I want you to see here is you should notice those values not approaching something. Those values are getting larger and larger. You can probably actually see the pattern, so that if I were to add another 9 on the x value, you can probably see what's going to happen on the y value side, the function value. But I want you to notice that those numbers are getting larger and larger negatively. And that's because, depending on what you remember from pre-calculus, is that there's actually a vertical asymptote at x equals 1. A vertical asymptote at x equals 1 if you were to graph this. And what that means is you can't approach a vertical asymptote, you can't touch a vertical asymptote. So what happens is instead the function shoots up, or the function shoots down towards infinity or negative infinity. So in a case like this, you really just have to decide, is it heading towards positive infinity or is it heading towards negative infinity? And just by looking at the values that we see here, we see that the values are getting larger and larger, but negatively. So our answer here is that the limit is negative infinity. Now that is not a real number value, but it is what the limit is. So I'm going to talk a little bit more about that. So notice it's saying if the value of f of x gets larger and larger without bound as x approaches some number from the left-hand side or the right-hand side or both, then we say that the limit as x approaches a, or the left-hand side or the right-hand side, and we know that that value is infinity, either positive or negative, and so you can see how we write that, which is just how I wrote the last one. And then a couple notes on that. So technically, you want to understand that infinity and negative infinity are not a real number value. They are not L, because they are not some number that we can quantify. So technically, the limit does not exist because positive and negative infinity is not a real number. Oh, this tablet. Okay. Okay. But if any of the above cases occur, so you end up with that, you will have, like I said, a vertical asymptote at, and then of course, whatever that value is, x equals a. So if a case like this occurs, all you really need to do, you don't even need to use a calculator for a question like this. You can just plug in your value. So notice in this case, we have a function. We already can tell if we plug in 2, numerator is going to be 4, denominator is going to be 0. Okay, so we would want to recognize that first, that we have 4 over 0, like this, and that that's not a real number. But anytime you have something divided by 0 in a case like this with these limits, that implies some sort of positive or negative infinity. Because what's happening if we approach 2 from the left-hand side, like we're being asked to here? We're looking at values like 1.9, 1.99, 1.999. And then just as an example, let's say we do 1.99. If I take 1.99 and I subtract 2, I get negative 0.01. And then if I cube it, as you can see in my denominator here, I'm going to get negative 0.000001. So what we're doing is we're taking, like this numerator is 4, if you plug in 2. If I plug in 1.99 and I square it, that's going to be a big number. Okay, that's, I mean, it's not huge. It's actually only 4, but it's not teeny tiny. But then I'm going to divide it by this denominator that I have, which is teeny tiny. And when I do that, I get, oh my gosh, I get negative 3,960,100. So I get this very large negative number. But that's always going to happen in a case like this. If you divide by 0, what's happening is as you're approaching the left and the right side on the x value, your denominator is getting very, very small. And something big divided by something very, very, very small is just something even bigger. And so that's what's creating the large values in the positive or negative direction. So now all you really have to think about is, are we heading towards positive infinity or negative infinity? And that just depends on the sign of the numerator and the denominator. So we can think about what would happen in the numerator and denominator if we were to plug in values close to 2 from the left-hand side. So notice the numerator is always going to be positive because no matter what you do, you take a value and you square it. Now in the denominator, like I already said, when I thought about 1.99, if I subtract 2, that's a negative number. And then if I cube it, a negative number cubed is still negative. So now we are seeing that no matter what I put in close to 2 from the left-hand side, I'm going to have a positive divided by a negative. And that's always going to be a negative. And so just by doing this and kind of thinking this out, we know that this is a negative infinity. So I'll put that here. There we go. And yeah, so that's going to be negative infinity because of the negative and because we have the implication of infinity. And that's all you have to do for problems of that type. So just a couple graphs in regards to those limits that we saw regarding infinity and negative infinity. So the first one we looked at was x plus 3 divided by x minus 1, and you can see that right here in the blue. So notice it's got an asymptote, and that asymptote is at x equals negative 1. So, of course, the biggest thing to understand here is just that when you look at this, as you're heading towards 1 from either direction, you are heading towards an infinite limit. So we looked at it as approaching from the left-hand side, values like 0.9, 0.99, 0.9999, those things, and that we're getting values that are, smaller and smaller and smaller and smaller and smaller. And that's why that limit is the negative infinity. The second one is fairly similar, just in terms of the fact that it is a rational function, as you can see. In that one, we were approaching 2, and we were approaching 2 as well from the left-hand side. And so if I put on that vertical asymptote, you should see that this function is also approaching that value, that it is, that as we approach 2, we are approaching the infinity or negative infinity. And because we were approaching 2 from the left-hand side again, we are also getting that infinite. But we could have been asked about this function and approaching 2 from the right-hand side. And if that were the case, then we would just have a positive infinity because we're heading up towards those values. So just really depends on the function. There are functions that I could probably come up with one pretty quick here. So here's me just modifying that second function just a little bit. And as you can see, in this case, both the left and the right-hand side limit is up to infinity. So you do end up with that in a case like this. It just depends on the function and whether it's even, odd, neither, depending on how it looks.